Okay, this topic is all about a protocol called DNS. So as a quick reminder, last time we talked about TLS, and in order to secure connections made over TCP, we did this long handshake. Remember that the client and the server exchanged random numbers. These prevented replay attacks across different connections. And then the server sent a certificate to prove its public key. Remember that knowing a certificate doesn't guarantee that the server is the legitimate server. It just tells you what the public key of the server is. At this point, this could still be an attacker. All you know is their public key. And public keys are public. Anybody can send this certificate. And then there's a step for exchanging secrets and proving the server's identity at the same time. RSA was one approach, but modern TLS uses Diffie-Hellman because it provides forward secrecy. So it's a Diffie-Hellman key exchange to learn the shared secret, and the server signs its half of the Diffie-Hellman key exchange. So in addition to sending this value, it also sends a signature on that value. The server can verify the signature. The client, can verify the signature using the certificate that it received, and that's how you know that this is the real server. And then they exchange MACs to make sure that nobody tampered with any of these earlier messages, and then we can start using symmetric key encryption using the keys that we derived to exchange messages. And in order to prevent replay attacks inside the same connection, we use record numbers, which you could think of as timestamps inside each connection. Then we talked about the security properties. Diffie-Hellman gives us forward secrecy. An attacker in the future cannot decrypt past messages because the secrets A and B from the Diffie-Hellman key exchange have been lost. It provides end-to-end security, which means that even if there are tons of man-in-the-middle attackers between us and the person we're talking to, we still have confidentiality, integrity, and authenticity. This is how you stop all those lower-level network attacks. You accept that there could be man-in-the-middle attackers, but you'll defeat them by using cryptography in TLS. However, we have to be careful. End-to-end security doesn't stop you if you're talking to an attacker. And TLS doesn't give us anonymity. Attackers can read the IP header to see who we're talking to. And there's no availability because they can mess with the underlying TCP connection. Then we said that TLS is used by layer 7 protocols like HTTPS. And finally, we said that trusting a third-party certificate authority is hard and relies on real-world human trust as opposed to cryptographic math trust. So that's it for last time. So today's all about a protocol called DNS. The first half is about how it works, and then the second half is about various attacks and defenses on this protocol.